Dear children, now you are going to study the fifth lesson in your textbook. The topic of the lesson in the textbook is pressure. This topic comes under the 3.2 competency level and it is given 6 periods to complete the lesson. In your teacher guide, it is given as utilizes the pressure exerted by solids effectively in day-to-day life. Once you follow this video carefully, you will be able to gain these learning outcomes. You should be able to explain the concept of pressure, taking the day-to-day experience as examples. State that force and the area on which the force acts affect pressure. Conduct appropriate activities to show that force affects the pressure exerted by a solid. Conduct appropriate activities to show that the surface area on which the force affects pressure exerted by a solid. Derive the relationship between the perpendicular force and the surface area. State that unit of pressure is newtons per square meter. Use Pascal as a unit of measuring pressure and solve simple problems, and accept that the factors affecting pressure can be appropriately changed the instances where the pressure exerted by the solid object need to be increased or decreased. So this video is totally prepared to achieve these learning outcomes. Now look at these different situations carefully. Think. You also have come across with some of these situations in your life. Just imagine if your leg is trampled by a lady with a high heel. Will it give you a crying pain? Or else if you have to take a chance to being trampled by an elephant leg? And also, in this situation, which trampling gives you more pain? With a regular heel or a high heel? Here is a very common situation that all of you have faced daily. When you look at the figure 5.1, there it shows that a boy with a narrow strapped bag, and his face gives that he carries it with very uncomfortably. And this one is in the smiling face, only difference is the stripe is broader. And in this situation, even both the bags having broader straps, this one is having a very less weight here. Here having a heavy weight. And in the next situation is it's little bit a funny situation. In a circus, sometimes this kind of situation might be happen here, which here actually you can see another one. Yes, what can you say about these situations, all these situations? I don't need any answer from you. Just think about the situations which hurts you a lot. As you know, our topic is pressure. To understand the pressure, we have to think about the factors affecting the pressure on solids matter. Here, especially I have to mention solids matter because for your syllabus, only we have to consider the solid pressure exerted on solids only. Now it's better to do this activity given in the page 61. First, collect these materials needed. You have to collect several cakes of soap, thin metal wire, several bags of sand with weighing 10 Newton each, a piece of plank which is longer than the length of the cake of soap and similar in breadth of the same, a stopwatch. Once you gather these things, you have to prepare the setup as given in the figure. Here you have to keep the soap on the plank, which is having a similar breadth but longer length. Bring two desks closer and keep that plank in between them, and tie up the wire around the cake of soap and put a hook there to insert the sandbags. In this activity, you have to change the increase the number of sandbags and see the time taken to cut through the cake of soap. So, when you look at the procedure, once you set the items as in the figure, first you have to hang a one sandbag which is weighing 10 Newton, and start the stop. When you hang this, start the stopwatch and measure the time taken to cut the soap by that weight. In the second instance, remove this. You cannot use it again. Put another cake of soap and hang the hook. Inserted two sandbags and again get the time taken to cut through the cake of soap. Likewise, increase the number of sandbags, thereby you increase the weight of the sandbags and measure the time taken to complete the cut the soap into two. What will you observe here? Sometimes in the first instance, this weight you could not be able to cut the soap by using a one sandbag. Reason is that weight or the force is not sufficient enough to cut the soap. But while you are increasing the sandbags gradually, you will observe that the time taken to cut the soap will reduce very quickly. Just think about if you put 4 or 5. So the time actually sometimes you cannot measure it even, because that is such a fast. So when you conduct this activity, two important facts are revealed. They are the force or the weight. This weight of the sandbag is the force effect to cut this soap. In other words, because of this force, it creates a pressure on this and cut the soap into two. That means force affects the pressure exerted on the cake of soap. Second one is pressure increases with the increasing force. So now we want to confirm whether that earlier finding is correct or not. Now let's conduct this activity 5.2. For that experiment you need different things. A piece of plank, it's a wooden plank with a size of 15 into 10 into 1 centimeter. Another plank 20 into 15 into 1 centimeter. So these two are wooden planks having the similar width. Again, wooden block you need to get 15 into 10 into 5 centimeter width, and a sponge with the size of 15 into 10 centimeter into 5 centimeter width. Here these widths are similar. And you need 4 nails, a ruler or a scale, and two weights of 2 kg and 5 kg, a hammer and a Newton spring balance. When you look at the materials, and it is a long list, so Even though this practical is very simple, but it is having a very lengthy procedure. So sometimes you may feel it as a very difficult one. So because of that, to make it easier, I will explain the experiment stepwisely. So be conscious and follow the steps very carefully. First, you have to fix the two planks in this L-shaped manner. Right. So then place the scale along the 20 centimeter long vertical side of the plank. Once you prepare this, you have to place the sponge on the horizontal plank as shown here. So it is given, the height of the sponge is given as the 5 centimeter. So at once, that means initially without keeping anything on the sponge, the height of the sponge is 5 centimeter. Then what you should do is you have to weigh the wooden block of 15 into 10 into 5 centimeter using the Newton balance. That is this wooden block. So for the easiness, I just put it as 20 Newton. After taking the weight, what you should do is you have to place this wooden block on the piece of sponge as the figure. Then it is obvious that here it is 20 Newton weight. So once you keep a 20 Newton weight over the sponge, it is obvious that the sponge will shrink to a certain extent. So now I'll take that reading as 4 centimeters. Remember, these are not the actual readings, right? For the easiness, I just put these numbers. Then you have to place the weight of 2 kg on the wooden block as shown here. Now it is obvious that now two weights are exerted on the sponge surface. Now what will you think? Whether you will see the same height as shown here, or will it shrink more? Yes, it is obvious that when you put more force, because of the pressure created due to this force, the sponge will shrink. So then the height of this sponge I took as 3 centimeters. Next, remove this 2 kg weight and put the 5 kg weight here. So now totally how much of weight you exerted here? 5 kg equals to 50 Newton, and the wooden block is 20 Newton. 50 plus 20 equals to 70 Newton at this situation. So it gives a very high amount of weight. So because of this force, what will happen? The sponge will shrink more and more. I took it as 1 centimeter. Now it's easy. Now I tabulate all these things in one place. Now look at them. Here is sponge only. These are the readings that you have to get. Force exerted on the piece of sponge, no force at the initial position. So now the reading of the upper edge is 5. No reduction in height. Right? When you kept the wooden block on the sponge, 20 Newton is exerted. Now the reading is 4 centimeters. Reduction of the height of the sponge is 1 centimeter. In the second instance, the wooden block and the 2 kg weight exerted 40 Newton. So it is the height of the sponge is 3 centimeters. So here it made a small mistake. 5 minus 3, it gives 2 centimeters. Then the last situation, wooden block and the weight of 5 kg on the sponge together gives 70 Newton force or weight, and reading is 1 centimeter, and the reduction of the height of the sponge is 4 centimeters. When you look at these readings, what you can say? Here we didn't change the wooden block, which is contact with the sponge. That means area kept constant. But here you change the force exerted on the sponge. And also you will observe that the created pressure, exerted pressure is increases. So again, let's see what are the important points to consider here. In each of the situation, the contact surface areas are same. We increase the force exerted on the sponge. So you will observe that the contraction of the sponge is also increased. Conclusion, pressure increases with the increase of force. That means we have confirmed the previous activity by this activity. In this kind of relationship, that means pressure increases, force increases. If we reduce the force, pressure reduces. That means there is a relation. This kind of relationship, we can say pressure is directly proportionate to the force. Let's do the another activity to find another factor which is affecting the pressure. Here we need again a cake of soap, a piece of thin wire with the diameter of 0.2 millimeters, a piece of thick wire with the diameter of 1.5 millimeters, a sandbag of weight 20 Newton, a piece of plank which is similar in breadth to the cake of soap. Here you can see I have highlighted these two materials. A thin wire with 0.2 millimeters, a thick wire having 1.5 millimeters. To get an idea, see this slide here, 2 millimeter diameter thickened wire and the high diameter wire. Now you can understand about the contact surfaces, right? Okay, keep that in your mind and let's move to the activity. As in the activity 5.2, you have 5.1, you have to set the things as this way. As the same manner, you place this cake of soap on the plank and kept it in between two tables and coil the wire. First you have to take the thick wire and hang this sandbag of 20 Newton. Here also you have to take the time taken to cut the soap by using these two wires. First you have to get the thick wire and secondly get the thin wire. So then there you will be able to observe that. What will you observe? When used the thick wire, it is difficult to cut the cake of soap. When using the thin wire, you can cut the soap easily. In day-to-day life, sometimes you may have seen that your mother use a thread to cut the soap easily without using a knife. So what can we conclude? Higher the thickness, that means it increases the contact area. Area is increased. Therefore, pressure decreases. So, to increase the pressure, what you need to do? Reduce the area. That means To increase the pressure, you have to decrease the area. To decrease the pressure, you have to increase the contact area. It's such a kind of relationship. How can we give? That means pressure is inversely proportionate to the area. In this activity, the most important thing is you kept the force in a constant manner, that is 20 Newton. For both the situations, you took 20 Newton. You didn't change it. But we change only the area of contact by changing the thickness of the wire. Yeah, these are some of the situations. We will discuss about this later on. Now, shall we confirm that finding by doing this activity 5.4? For this practical also, sometimes students may get them as a very difficult one. Even you didn't try to read these things even. So for this experiment, you have to gather these materials. A piece of plank with size of 15, 10 into 1 centimeter. Another piece of plank size 20 into 15 into 1 centimeter as the previous 5.2 activity. Then you need a wooden block and named it as A. The size is given. Then you need 3 sponges having 3 different areas. Here 15 into 10 into 5, 15 into 5 into 5, 10 into 5 into 5. The similarity is all these sponges having a similar height. Then 4 nails, hammer, Newton spring balance. As in the activity 5.2, what you have to do is first you have to take these 2 planks and make this L-shaped structure and place the scale here. Then weigh the wooden block. I took it as 20 Newton. So here you remember that you have 3 different sponges but only 1 wooden block. Now the weight of the wooden block was taken as 20 Newton. Now what did you do? You have to place the sponge B. A is the wooden plank. First sponge is labeled as B, kept on this wooden plank. And without keeping this one, you just get the height. It is given here also. The height is 5 centimeter. So then place now the sponge area is 15 into 10 in 10. The contact area is 15 into 10. So you have to place the similar side of the wooden block here. Here that wooden block is 15 into 10 into 5. So you have to use this area 15 into 10 over this. Then it is obvious this wooden block is a 20 Newton weight. So definitely it should create a force over this sponge. Now what will happen? What do you think? Can you get a similar height of the sponge as the earlier 5 centimeters? No. It will definitely, because of this heavy load, the sponge will shrink to a certain extent. Now here I took it as 4.5 centimeter. Then what you should do? Remove that sponge B and place the sponge C on the plank. Place the 15 into 5 centimeter surface horizontally. Now we have to get this area 5 into 15. Then what you should do? Your wooden plank also have 3 sides. So get the 15 into 5 centimeter surface and kept it over the wooden sponge. We took the same wooden block, but changed the side. Now what will you observe? Whether it shrinks the similar amount or whether it shrink more. Here actually what will you see? You will observe the sponge will shrink more. I took it as 3.5. Now remove the sponge C and place the sponge D here and get 10 into 5 centimeters surface area. 10 into 5 centimeters. And also you get the block of wood block and keep that similar surface area over it and get the reading. There you will get the reading as 2 centimeters. Now in this activity, remember that we kept the force constant because we took the same wooden block, but we changed the contact area of the wooden block on each piece of the sponge. So that this is the changing factor here. But we kept the force constant. For all these things, all the readings, I put it into this table for easy understanding. Here sponge B, the height of the sponge is 5. When the wooden block contacts 15 into 10 meter centimeter surface, the force exerted on the 20 Newton. Contact area is 15 into 10 is 150 square meters. Height of the sponge now after shrinking 4.5. So shrinking reduction of the height 0.5. Here sponge C only, again 5 centimeter. And wooden block weighing this area 20 Newton. But the area is 15 into 5, 75 square centimeters. Height of the sponge now 3.5, reduction 1.5 centimeter. Sponge D only, again 5 centimeter. When the wooden block contact is 10 into 5, the same weight, but the area is 50 square centimeters. And height of the sponge is 2 centimeters. So the reduction is 3 centimeters. Here it is obvious that we kept the force constant. Here you can see reduces the contact area and increases the reduction of height. This, remember that reduction occurs due to the pressure on the sponge by this force. So when the contact area, we can conclude that higher the contact area give less pressure. Lesser the contact area gives high pressure. So therefore this activity confirms the previous finding, that is pressure is inversely proportionate to the area. So this is actually the summary. I think no need to explain it again. Anyway, accordingly it can be concluded that pressure exerted by a solid object on a solid surface depends on the surface area on which the force is acting. Higher the surface area, pressure is low. Lower the surface area, having a higher pressure. According to the above two activities, in the first one it is confirmed that pressure depends on the perpendicular force acting on the surfaces. That means 5.1 and 5.2 activities. 5.3 and 5.4 activities concluded that surface area also affect on the surface area on which the force is acting also affect on pressure. So now you are in a situation to give a meaningful definition for the term pressure. It is the perpendicular force exerted over a unit area. So, perpendicular force. Pressure is a perpendicular force exerted over a unit area. That means pressure is a kind of force and it's exerted at right angle to the object and exerted downwards by a solid matter. If the area a force acts on is small, the greater pressure will be given. If the same force applied to a large area, the pressure will be reduced. Now we can write these findings into a formula as this way. Now it's time to find the units of pressure. Force is measured in Newton, area is measured in square meters, so the unit is newtons per square meter. It is found out that 1 newtons per square meter is equal to 1 Pascal. So whenever you solve the problems and get the answer in newtons per square meter, can be kept in Pascal. Just put in PA. Here is the formula triangle, which actually I put this formula triangle here to emphasize 3 things. This is the original equation. Pressure is equal to force and area. From this original equation, you can derive 2 more equations. If you want to find the area, what you should do, you have to equate area by crisscrossing it, force into pressure. If you want to force, what you should do, you have to get the area here and area into pressure. Here it is, you can remember this triangle very easily. Pressure is equal to force divided by area. Area is equal to force divided by pressure. This line shows you force divided by pressure. Force is equal to area into pressure. Okay. I think it's better if you can memorize this formula triangle, so thereby you can solve the problems very easily. Now it's the time to see how far you could remember, how far you could understand the concept. State which gives high pressure and the reason for it. Take these situations one by one. Here, regardless of the weight, you take the contact area. Here, so in this high heels having less area and this feet has a high area, so this situation gives you more pressure due to the less contact area. In this situation also the same. The one pointed finger gives you more pressure than the palm. Here also the same, the nail or this object having a very blunt edge. Here the object having a very sharp edge, that means the contact area is less, so it's easy to fit into the wall. Here this picture you have seen earlier also. Here actually you can see the same elephant in the lower. So that means the contact area is same. But in this A situation, more weight is given than the B. Because of that, A gives the high pressure. And look at these dancers, positions of the dancer. Which position of the dancer gives the highest pressure to the floor? That is also, you have to think logically. In the first instance, the dancer kept her 2 feet. Here 2 feet but in toes. The contact area in this first situation is higher than the second situation. So giving more pressure compared to the first. In the third instance, the contact area is much more lesser than the first two instances because she balances her body in one toe. So, but the body weight of the dancer does not change in the three situations. Same force is given but changing the contact area. Lesser the contact area, again higher the pressure. Here, these three situations are very common situations in our day-to-day life. If this is a car park, because of the rain that field become muddy. Now what you should do to bring the cars back to the normal road safely without being sinking. Here you want to go along this muddy area without getting sinking in this muddy. And here you want to put a camp tent on a muddy field. How would you, or what actually has to be done, or what is the principle behind them? Here, what you should do, you have to reduce the pressure. In these three situations, you have to reduce the pressure. To reduce the pressure, what you should do? You have to increase the contact area. So then in here, by placing some sheets here or boards here, you can get the cars safely. Here also the same, you can place a wooden plank or bricks, so thereby you can increase the contact area. Here also the same, placing a wooden plank here, you can fix the tent safely and steadily. Now I think I have to raise a question to you. What is the reason for studying these concepts of pressure? Now you learn about what is pressure, what are the factors affecting the pressure, why, what is the purpose? Yes, if we want to use or control something, you must know about the subject. Here also the same, because pressure is a kind of force that is very, very useful to us if we use it in a correct way. So if we know the factors affecting pressure, you can control it. Certain situations you need to increase the pressure, certain situations you need to decrease the pressure. If you don't know the factors affecting pressure, you cannot control them and utilize for the benefit of mankind. That is why this lesson is put into your syllabus. Just take an example. You want to cut easily. You know that you cannot do it with a blunt blade. What you should do, you have to sharpen the blade. That means you reduce the surface area. In same manner, you need a very small surface area when you are using a nail, needle, scissor, drawing pins or spade. But in some situations, it is essential to get high surface area. If you want to build up a 3-story building or 5-story building, you need a larger foundation. Why? To prevent the sinking because of the heavy load of the building. And you need high surface area in snow shoes, otherwise you will sink in snow. Tires of caterpillars and tractors and vehicles carry heavy loads. There it is very common to use very large number of big tires having surface areas. Now do the assignment. This is given in your textbook. Try to do these problems. You can use that formula triangle. These are very easy problems. Here also this one also the same. All the facts are given. What you should do is you have to read this carefully and use the formula and find the answer. Once you finish this answering the given problems, answer the exercises given in the textbook. Hope you may get some idea about pressure. Please do not forget to write comment underneath. If you think this is useful, please share the link with your friends. Thank you for watching the video. Hope to meet you with the next video.